The earth shall not be considered an effective ground fault path. That's a true statement. They'll use that as a true false on the exam. The earth cannot be considered an effective ground fault path. The reason is every time the sun comes up, the earth gives up its moisture in the top 10 inches of soil. When the moon comes up, that moisture restores. That waning change in moisture content makes the earth a very bad ground fault path. Because if you had a fault at midday where your moisture content is at the lowest, you would not get reactivity. It would have to occur under full saturation, like in the middle of the night. So this is why it's a true statement, and they ask that on the exam as a true false. Can the earth be considered an effective ground fault path? No. So now, with that said, turn to 250, 122. Where necessary to comply with 250.4A5 or B4, which is what I read to you, and B4 says the same thing, the equipment grounding conductor shall be sized larger than given in this table. In other words, you go up, never down. So in illustration, a 15 amp breaker gets a 14, a 20 gets a 12, a 30 gets a 10, a 40 gets a 10, a 50 gets a 10, a 60 gets a 10, a 70 gets an 8, an 80 gets an 8, a 90 gets an 8, 100 gets an 8, 110 gets what? Number 6. Always go up. Always go up. If it is a general piece of equipment, use this table. If it is a design specification equipment, go look in that cabinet and find the largest ground. All right. You will have 2 of these on the exam. So now, back up to table 102C1. And by the way, if you want to make the note over the table, removal of impedance, you will have both your jobs. Removal of impedance, now every time you see the word impedance in the code, you know what they're talking about, and equipment grounding conductor. So now you got both the jobs covered. Over table 102C1, if you'll write unbalanced return current, you got both those covered. Now, in like fashion, the header gives it away. The grounded conductor is listed first, and right behind it is the main bonding jumper, which supports what I said. Main bonding jumper is to back up to the grounded conductor. Now is where we shift gears. We find out that it says you will size it based on the largest ungrounded conductor. So what size in copper would I need for the grounded conductor if I wanted it in copper and my phase conductors were 350 MCM? Very good. Did anybody say number 2? Good. That means you're paying attention. Be careful of these tables. On the exam, they will always give you something that falls on the break points. They'll never give you something that falls in the center. They'll always give you something that falls on the break points. And that is why you can miss these. They're very straightforward, but it's these other little nuances that'll mess you up. Because when you read the table, it says through 350 and over 350. And you will find out that those other numbers are there. So you don't get a red flag that you made a mistake. See, there's the problem with this exam. There's nothing to throw a red flag that you messed up. You're going to see all your wrong answers. When you say over 350 and you said a 1-0, were you right or were you wrong? Huh? You were incorrect. Every one of you. I said your phase conductors were 350 MCM. That says through 350. So the correct answer is, guess what? 2. I said in copper, 350 MCM. It says through 350. Then it says over 350. I didn't say over 350. Every one of you just missed that question. Do you see my point? This is why they do that on the exam, and you didn't even catch it. That's why I followed up and said, did anybody say 2? Do you see the mental efforts that's got to be put into this exam? So anxiety is not your friend, which is why I've done what I've done to try and remove all the anxiety so you can maintain your focus. That's why they're going to give these things to you on these known breakpoints. 1-0's going to be there staring you in the face and you're going to feel like you got it right. One guy called me on the phone. He said, "You're right, Victor." He said, "I saw every one of my answers." He said, "There was nothing there to make me feel like I had missed anything. Because even when I did the calculations and left something out, I saw the answer. And said, oh, there it is, I got it." Which is why you either know this or you don't. And that's why on these tables, take the bottom of that scrap paper and put it on these tables and make a straight line. And read the detail. It says through 350 and over 350. See, here's the problem with this exam. All these onesies, the best way I ever heard it said was from an old guy who ran, I knew, a pawn shop. Pennies make nickels, nickels make dimes, dimes make quarters, quarters make dollars. You say that all the time. Well, all these onesie twosies we're talking about that you miss add up to a nickel, then a dime, then a quarter, and guess what? We made a 69.
Not a good feeling.
Not a good feeling. You're right there. You're right there. That's why this detail is so important. That's why I said there's no fluff in this class. That's why this class is so valuable. If I don't point out these nuances, they are the very things that destroy you on this exam. It's not that you don't know the information. It is all these little details that if they get left out, you end up losing the day. You've got to maintain your focus. You've got to go in there with a plan. You have got to look at this detail. You have got to connect these dots. Through 350, in copper, a number 2. If they'd asked for aluminum, you'd have been good. Because then it would have been a 1-0. Have I made my point? Okay, be very careful with this table specifically. Okay? Now, here's a cool thing. Now that you know the jobs of the conductors, this is where we see conjoining questions on the exam. They'll say, size the grounded conductor. And you'll answer that question. And now you've got your ledger So guess what the next question on the exam is? Now size the bonding jumper. Well, guess what? We know it's the backup to the grounded conductor, which means it's got to be the same size to do that job. They can't fool us now. See the beauty of it? Don't even have to think about it. Oh yeah, well, if they still want it in copper, that's the same answer. The only way they could change it up is now tell me what it would be in aluminum. Still going to be the same size. One's primary, another's backup. Makes sense now. Now you got two of these, but there's one more. Two off the table, now one more. The next one is off the note under the table. So get your calculator ready. We've got to do a little calculator work. So now, I got to fix your book first. So I'm going to read the note. Note 1 under the table. The ungrounded supply conductors are larger than, if the ungrounded supply conductors are larger than 1100 kc mil copper or 1750 aluminum, the grounded conductor or bonding jumper shall have an area not less than 12.5% of the area of the largest ungrounded supply conductors or equivalent area for parallels. First thing we want to do is convert our book. So circle 12.5%, draw a line to the margin, and at the end of that line, write 0.125. 0.125. That is the digital equivalent of 12.5%. Now we're ready to go. Now I'll show you how to do it. Turn back to Chapter 9, Table 8. Page 705. When we get there, we are looking for area. Inches squared. Area. When you look at that table, it says diameter, diameter, and it says area in overall. Inches squared, IN 0.2. Now, the first thing to recognize is we must be larger than 1750 in area. And so what we find out is that we need a conductor that is roughly larger than about 1.1 or 2 inches in diameter, okay? Or not diameter, but area. So basically, let's choose to run two 700s because the area of a 700 is 0.730. And when we run two of those, that gives us an area of a little over 1.4. So that is definitely larger than 1100 kc mil. So now the way you do it is you take your calculator, and on the exam they will give you the conductor. Okay? So now that 700, we're going to run two of them. So we go 0.730 times 2, and we get 1.46. Now we multiply 1.46 times 0.125. We get 0.825. Make that a 3-digit number. 0.183. Because you're at the roll up of 0.5. 0.183. You there? Now slide up that column and find me a conductor that 0.183 will fit in. For all. You're now the project hero. This works all day long. You'll be given one of these. They will give you what they want you to run in either parallels or triples. The execution is always going to be the same. Whatever they give you, we can do another one. We'll do another one. Let's say we're going to run triples. It doesn't matter. We're on a job. We got to solve a problem. We need to find the size of the grounded conductor, and we decided we're going to run triples now. So let's say we're going to run, give me something y'all want to run in triple. What do you want to run in triples? 500s? Those are real common, aren't they? All right, you got 500. You want to run 3 of them per phase? 0.519. 0.519 times 3. I got an area of 0.1557. Now, times 0.125, I get 0.1946. Make it 195. So slide up the column. It'll still go in that 4-aught, won't it? You can do them all day long. You're dead on the money. About 3 or 4 years ago, teaching this method, I had a student in class for CE, and he said, I did this on one of our projects after you taught it to me, and the inspector came, looked at me and said, where did you learn that? Show me how to do that. It's very valuable. Now all you got to do is go pick your installation. You're going to have one of these on the exam. Now you know how to do them. Everybody got it? I don't just teach exam prep. I teach real life. Because the way I look at it is you're about to go get qualified, and that's the equivalent of me handing you a 357 Magnum and saying, go have a good time. If I don't really tell you how things work, you're going to end up shooting yourself in the foot. So I got to explain to you how that 357 Magnum works. That's what this is all about. I can get you ready for exam prep, but what I can't get you ready for is the first time you take that contract and actually go out here and try and execute some of this work. If I don't teach you how to use that weapon correctly and safely, you're going to hurt yourself. This work is the same way. I don't want to see you go out here and get in trouble. I want to see you succeed. And so if I don't explain this stuff, it stays an abstract, and the first time you try to use it, if you don't understand it, you can mess up very badly. So there's the reality of it, which was a good point to be made. One of the things to understand is if you call a parts house and say, hey, I want to order 200 or 300 feet of a 1100 KC mill, you're probably going to hear them popping the phone on the counter going, hello, what? What did you say you wanted to order? Because they know that unless you're working some extremely large projects, more than likely you're that guy who called up and said, hey man, I need 1,500 feet of 350. See, there's a reality to this. Most guys don't go buy big wire unless it's been spec'd out.